Okay, now we are going to study about the complex substitute. Complex substitute means any side chain further containing uh, side chain. Already it is a side chain, but it is going to contain one more side chain. Let us take an example of CH3, CH2, CH2, CH. Here CH and CH3 and CH3. Okay, then it is CH2, 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 CH3. Okay, so basically this is a main chain. This is a main chain. So on this main chain, side chain will be this one. This will be the side chain. Ethyl is basically side chain, and but ethyl further contains one more side chain. One more side chain. This is called as a side chain to side chain. Okay. So now here complex substitute is this one. This is called as a complex substitute. So complex substitute means I think it is clear. So any substitute, it is already a substitute on the main chain. It is a substitute of hydrogen of the main chain and it is further containing a substitute. Okay. This type of substitute are called as a complex substitute. And for this naming, a special rules and special format is followed. Okay. So let us take here, if I am numbering from left to right, this will be 4, and from right to left 1, 2, 3, 4, 5. So if I number it, this is called as locant, and this, if I am numbering from this direction, it is 5. If I am numbering from this direction, it is 4. Therefore fourth is the correct one. Okay. Now complex substitute will start with the number of the locant and bracket. Okay, and here it needs to be further numbered. It needs to be further numbered. This numbering also always starts from the carbon with which it is attached. Carbon with which it is attached to the main chain. So this carbon is attached to the main chain. Therefore this will be definitely one only, irrespective of all rules. This should be numbered. Okay, then one is containing methyl group. So this will be 1, and this I am using other color only to specify that this is this numbering and this is this numbering. Okay. The main chain numbering will be outside the bracket, side chain numbering will be inside the bracket. And on the first carbon it is 1 methyl. On the first carbon it is 1 methyl. Okay. 1 methyl. That means we are able to write the substitute. We are able to write the substitute to substitute 1 methyl, and it is substituted on the ethyl. So only first letter will be capital, 1 methyl, then it is ethyl. 1 methyl, ethyl, bracket close. Then we should write about the actual main chain. Actual main chain is containing 1, 2, 3, 4, 5, 6, 7, 8. So octane. So it is octane. Okay. So this is about the writing, a simple example of writing the complex substitute. Complex substitute. Okay, this is a simple example which contains only one complex substitute. If it contains two complex substitute of the same type twice, then instead of di, in the normally we will use dimethyl, trimethyl, but if the complex substitute is available two times, then we use bis. If the complex substitute is available three times, then normally we will write as a tri. We are going to use here tris. Okay, this is bis, this is tris, and if four times it is available, normally we will write as a tetrachloro, tetramethyl, but here we are going to write tetrakis. Okay, so this is the special wording used when same complex substitute is available more than once. Same complex substitute is available two times, then it is called bis. If it is available three times, then it is called tris. If it is available 4 times, then it is called tetrakis. Okay. So let us take here example. In the same thing I am going to change so that concept can be understood very easily and fast. Okay. So here I am writing it same substitute. Okay. Same substitute is again available on the this carbon only. Available on the this carbon only. Okay, this is the carbon. Above also it is available, and it is not necessary. It can be available on the same carbon. It can be on the any other carbon. So I will take it on the this carbon. Okay, to this carbon, K same complex substitute is available. It should be same complex substitute. Okay. Now this is also 1-methyl ethyl. This is also 1-methyl ethyl. So if I numbered from left to right, so therefore it is going to be 3 comma 4. One substitute is available on third carbon, second substitute is available on fourth carbon. Total how many? 2. So if they are 2, then we will write it as a bis. Okay. So total name it is going to be 3 comma 4, 3 comma 4. Okay. First is available on 3, second is available on 4, total 2. And what are those? 1-methyl, 1-methyl ethyl, 1-methyl ethyl octane. 1-methyl ethyl octane is the complete name of the substitute if it contains 2 complex substitute. If they are available 3, then this will be changed as a trace and that number will be mentioned here. Okay. So this numbering always don't forget that this one is of the side chain numbering. Whatever the number we will mention inside the bracket, that is the number of the side chain. Whatever the side number we write on the before that will be number of the main chain. Okay, this is number of main chain, number of main chain. This is the number of the side chain. Okay, like this, if the chain is given like this, main thing is you should be able to differentiate normal chain and complex side chain. Okay, always we should prefer to avoid the complex side chain. So if I take this straight chain as a main chain, then I am able to cover 9 carbons only in the main chain. But if I move like this blue color circled chain, I am able to accommodate maximum number of carbon atoms in the main chain. Always we should try ourselves so that we should accommodate maximum number of carbon. We should accommodate maximum number of carbon in main chain. Okay, maximum number of carbon in main chain, that is the first thing we should try. And second thing, maximum side chains. Maximum side chains. Okay, maximum side chains. And third thing is minimum complex substitutes. Minimum complex substitutes. Okay, because we don't want anything to be complex. Okay, so for that, minimize the complex substitute, maximize the side chain. So according to that, this is the best possible chain. Now I will circle the complex side chain with the let us say green color. Okay, only this is complex substitute. This is a substitute, and this is the side chain to the side chain. Okay, and there are normal substitutes also. So this okay, this is a normal substitute and this is a normal substitute. Okay, so for them you can write the number of the this number only before here, this number, and inside the bracket this is the one number. This numbering is to be done only for the complex substitute. Okay, so now let us go for the lowest sum rule. So if I am going for the lowest sum rule from the left to right, it will be one. Locant will be 2. Okay, I will use the other one. Locant will be 2 Okay, this is the first locant, and second locant will be 5. Second locant will be 5. Okay, third locant will be 7. So 2 plus 5 plus 7. 2 plus 5 plus 7. That is equal to 12 plus 2, 14. So if I number from here, then it is going to be, if I number from here, 1, 2, 3, 4, 4, 5, 6, 7, 8, 9, and 10. Okay. So locant as per this numbering will be 4, and then next it is going to be 6, then next it is going to be 9. So anyhow we are getting maximum number here, so you should avoid them. Okay, so 14 is the minimum possible number. Let us go for the numbering of 14. Okay, now here it is methyl, it is propyl, and it is ethyl. So which is to be written first? According to alphabetical order we should follow. Okay, so it is going to be 7, 7 ethyl, 7 ethyl. As per the lowest locant rule, this is the seventh carbon, it is containing 7 ethyl. Then comes the methyl and propyl, MNOP. So methyl comes first. Then it will be 2 methyl. Then it will be 2 methyl. Okay. And see, this methyl should not be considered. For the alphabetical order, the main substituent alphabet only to be considered, and it is available on the fifth carbon from left to right. So it will be 5. Okay, 5, then 1 methyl propyl, 1 methyl propyl, 1 methyl propyl. Okay, 7 ethyl, 2 methyl, 5, 1 methyl propyl, and total number of carbons are 10. Therefore, it is going to be decane. It is going to be decane. So this is some new example, different example for the complex substitute. In this example, you will able to understand, differentiate between normal substitute and complex substitute. If all together comes, how to do the numbering and how to arrange them, which is to be considered as a alphabetical order. I think all these concepts are understood with this example. Okay, this is another example. In this, your some more concept will be clear. Okay, so this is the main chain. Straight chain is the main chain, and it is consisting of two side chains. Side chains are propyl, and each propyl is consisting of two side chains. That is two complex substitutes with the further two substitutes on each. Okay. So now these methyl are to be numbered, are written as a die. Okay. So first of all, 5 and 7 both are having same type. So it will be 5 comma 7, and it is a complex substitute. Therefore, we should write 5 comma 7 bis. 5 comma 7 bis. Now bracket start. Okay. And on the fifth also propyl and seventh also propyl. And this numbering is side chain numbering. Okay. This numbering is side chain numbering. So 1, 2, 3. On that 1, 2 dimethyl. On that, what is that? 1, 2 dimethyl. 1, 2 dimethyl. See here, inside the bracket it is normal substitute, that's why di. Outside the bracket bis, because we are talking about the complex substitute. 1, 2 dimethyl propyl. 1, 2 dimethyl propyl. On propyl, first and second carbon contains methyl. And this entire complex substitute is available on fifth also, on seventh also. That's why it is 5, 7 bis, 1, 2 dimethyl propyl. Okay, and total 11 carbons are there. So undec, and single bond is there, an. Okay, so 5, 7 bis, 1, 2 dimethyl propyl undecane. I think it is now clear with the complex substitute. Okay, with this, all the examples and rules, your complex substitute naming must be perfect, and try yourself and clear your doubts. Okay, more practice is required for the complex substitute. These type of things you can only understand. You can only understand by practicing more and more questions. Okay, all the best.